Hey guys, so moving ahead with our discussion. Um, for this particular discussion, we'll be using a slightly different topology again. You can see here on the screen, I have like multiple areas, right? Because we'll be talking a bit of that. So we have area 0, 10, 20, like so these three are basically your OSPF. I also have some external protocols like your EIGRP over here and the RIP protocol over here, right? I've already configured all of this, which means I have already configured the area 0, area 10, area 20 of the OSPF as well as the other protocols, right? So we will directly use this topology to understand some of the concepts, right? To start with the redistribution, right? Redistribution is something interesting. Now if you look here, in order to talk between the routing protocols, right? So when I say that, it means that between OSPF and EIGRP, right? If I want to talk between them, or if I want to talk between RIP and OSPF, what do I have to do? I need to do something called as redistribution, right? So redistribution of EIGRP and OSPF, right? So if you see here the router R1, it's basically called as the ASPR. It's called ASPR because it is the autonomous system boundary router, right? Whereas the routers R2, R3, they are basically called as your ABRs, right? Because they are area boundary routers, within the OSPF. Whereas ASPR is something which is going to provide you that boundary, between the routing protocols, right? Similarly, R6 is also a ASPR because it is kind of like the boundary between the OSPF and RIP. Okay. Now let's see how we can go and redistribute our, probably OSPF into EIGRP, right? Let me do that. So let's go down to router 1, right? So because this is the ASPR, right, it is having both the EIGRP routes and RIP routes, but we need to redistribute EIGRP inside the OSPF. At the same time we need to do the vice versa, right? Redistributing OSPF into EIGRP. So let's see how do we do that. So let's go down to router 1, right? So if I have to show you my configuration, show run section router. So this is my configuration. I have my EIGRP, I have my RIP, right, already configured, right? So now if I have to do the first thing, which is go inside EIGRP 100. So what I'm trying to do, I'm trying to redistribute the OSPF routes inside EIGRP, right? So you need to use the command redistribute. What I'm redistributing, I'm obviously redistributing OSPF, so you need to write the protocol. Process number is 1, right? This one, put in that. Now the next interesting thing is just doing this is not sufficient, right? Why? Because if you look at EIGRP, it uses different metrics. It uses bandwidth, delay, reliability, load, MTU. So there are 5 metrics which are needed for EIGRP, whereas for OSPF it's just the cost, right? So there is a mismatch of the metrics. So when you are redistributing such kind of protocols, you need to also send in the metrics, right? You need to specify the metrics what has to be used once it gets redistributed. So now we need to, because we are redistributing the OSPF routes inside EIGRP, we need to give some value to the metric, right? So it could be any dummy value because it won't be used here because we have just it's redistributing, right? That's the only way to reach that particular network. So these values don't have any kind of significance, but still you need to explicitly give some initial values to the metrics, right, while redistributing any OSPF routes into EIGRP, right? So now once I do this, so I have redistributed. So now if I go to say router R7, it should have my OSPF routes, right? Let's see, does it have? So let's clear the screen a bit. Enable show IP route. Okay, so you can see here on R7 you can see the routes which are tagged as EX, right? These are the external routes, and you can see the external routes, the 2, 3, 4, 10, 11. So these are all nothing but my OSPF routers, and you are able to see those routes on my R7, which is predominantly only a EIGRP router, right? It's only having EIGRP, but it is able to see these routes now because we have redistributed, right? Now just doing this is not sufficient. We need to redistribute also the other thing, right? We need to redistribute EHRP into OSPF as well. So let's go inside R1 and let's do router OSPF1, right? And we do redistribute EHRP 100. Okay, and here don't have to uh, we don't have to define the metric like we did earlier, because OSPF has default metric, and the cost is 20, that is injected by default, so you don't have to explicitly do metric and put it, right? And the other thing which I also want to call out here is that in the older IOSs, OSPF was injecting only the major networks, right, by default. Like for example, if I go to R7 and if I show you show IP interface brief, right? So you see here you have the 7 network 7.7, or maybe I can show you show IP route include connected, right? So this was basically a major network, right, because it's a class A and has a mask of /8, whereas this is clearly your subnet, right? It's a /24, so it's like a subnet in the major network, which is 77.0.0.0, right? So OSPF was only injecting the major networks, whereas subnets you had to manually specify it. But in the new OSS it is doing it by default, right? So you need not explicitly do it. So I could show you that. So I go back to my R1, and when I hit the enter, right, let me just show you now. Show IP show run section router, right? You can see here under OSPF you can see the redistribute EHRP 100 subnet. So this is being added by default. I did not add this, the iOS automatically added it, right? Great. So now if I have to go to my R2 and see if the redistribution worked properly, right, what do I have to, let me clear the screen. So I have redistributed my EHRP into OSPF, right? So if I do show IP route, right, and it is included, you can use the tag of, because it will have O and E as the tag, right? So you can see OE2, right? So that is basically your this is basically your Ethernet EHRP routes which got injected. So this is the tag. External routes always have a tag of OE2, right? So these are your EHRP routes which were now injected, right? You can see the 7, 8, right? They are basically nothing but your 7 and 8 from here. So they are getting injected into your OSPF, right? So that was redistributing. So we redistributed successfully. Now similarly we can also go and redistribute here, right? In the bottom you see you have RIP and you have here OSPF. So I have to do the redistribution. I should do this on R6 because that is the ASPR. So if I go to here, so let me do both of these in one shot, right? So if I go here, I can go to router OSPF, right, 1, and I already have RIP, right, reconfigure. So I can do redistribute RIP, and I need to use the command subnets. Okay, similarly I can go to router RIP and I can say redistribute OSPF inside RIP, the process number is 1, and the metric is needed because RIP uses the metric of cost, so you just put 1 over here, right? By doing this your R5 will probably now end up getting the RIP routes as well. So I can do the same thing which I did here. Let me take this, probably go on R5 because I'm doing R5 because you can see here this is my R5, right? I'm just seeing if the routes came in successfully. So there you go. So I have the routes from RIP, which are my RIP routes. You can see these are my RIP routes, right? The 109, these are the ones, or 99. So this is actually my RIP network, so that you can see them here. Great, awesome. So that was redistribution. Now while we are talking about redistribution, we can talk about some different types of LSAs which are involved here, right? So let's talk about the type 5 LSA, right, which is the external LSA. The EHRP route that got redistributed into your OSPF, right, the ones which we saw here, these are your EHRP routes which got redistributed into OSPF. So these are actually nothing but learned via type 5 LSA, right? So it will appear as OE route in the routing table, right, and you can see that it will basically tell you that to reach any of these networks, to reach any of these external networks, right, either 7, 8, 88, whatever it is, you have to go through 12.1, which is nothing but your ASPR, right, which is this one, R1, right, it is 12.1, right. So now if you look at the topology here, right, so that is basically a type 5 LSA, right. Type 5 LSA is basically generated by your ASPR, right, and ASPR advertises it, and it tells the routers that, hey guys, you want to reach anything outside, you want to reach any route in your EIGRP or external domain, please go through me, right. And that's okay, because this particular basically your R2 and R3 will understand this, right. If you look at the, if I have to show you in the LSP database, you can see here, show IP OSPF database and external, right. So this is a command for looking at the type 5 LSA, right. So if you see here, it basically tells you that to reach any of these networks, right, you have to 1, right. So let me just scroll down a bit. Yeah, so yeah, great. So if I go back up here, yeah, so it's basically telling me that so this is basically my which one, type 5 LSA, right. So it is basically telling me that if I want to reach any of the networks, say the 8 network, right, external network, I have to go through the router ID, which is 0.0.1, right. And if I want to go to 7, I need to go to 0.0.1, right. The 88 network, the 99 network, so basically it is telling me that every time I have to reach the external network, I have to go through the ASPR, right. For the EIGRP, the ASPR is 0.0.1, and for the RIP network, the ASPR is 0.0.6, which is R6, right. So this is what it is telling me. Now if you look carefully, R2 and R3 will understand what is 0.0.1, right, because they are in the same area, right, and they know in their link state database, they know that 0.0.1 is basically R1. But when type 5 LSA, right, when it is advertised into another area, say this area 10 or area 20, right, we have already learned what is summary LSA, right. So as a result of that, when this LSA basically goes out, right, in R4 and R10 will not know who 0.0.1 is, will not know who R1 is, right, because ABR, whenever it sends, it basically sends a summary LSA, right. So when ABR propagates a route from your ASPR into area 10, then ABR needs to tell the routers in area 10 how to reach your 0.0.1. So ABR sends out a new LSA which tells that in order to reach your R1 router, it has to go through your ABR. So that is your type 4 LSA, right. So type 5 and type 4 are kind of like connected. Type 5 LSA is basically the external LSA, right, which is advertised by your ASPR, right, and that can be only understood by the routers in that particular area, in this case R2 and R3, because they know who 0.0.1 is, right. But at the same time, this LSA, once it reaches your R4 and R10, or in this case R5 and R6, they basically don't know who 0.0.1 is, because they are in different areas, right. So now the ABR basically takes the initiative to send out a new LSA, right, which basically tells that in order to reach your ASPR, you have to go through the ABR, right, and that's your type 4. Okay, so we looked at what is your type 5 LSA, we saw type 5, so let's also look at type 4. Now type 4 is, like I said, it is advertised by ABR, so ASPR will not have it, right. So ASPR will not have any type 4, okay, so which means on R1 you won't find it. But at the same time, we will be able to see the type for LSA on probably R2, R4 and R10. So what we could do is we could probably look into let's say R2. Let's go to R2. What we'll do is let's clear the screen. We'll do show IP OSPF database, and the command is ASBR summary. So this is basically your type for LSA. This is how you look at it, right? So you can see here for area 10, this is the one which it is advertising. It is telling that if you want to reach the R1 router, please come through me, please go through R2, right? This is 0.0.1. It is also telling that if you want to reach R6, because that is also an ASBR, right, for RIP, so it is telling please go through me, right? So right, so this is what I wanted to show you. So similarly, type 4 will also be on your R4 and R10 as well, because this is the one who is advertising it, right? So just to recap, type 5 is something which is concerning your external routes advertised by ASPR, right, which will basically indirectly tell you that if you want to reach any routes in behind R7 and R8, right, you'll have to go through me. But that can only be understood by R2 and R3 because they are in the same area. They know who R1 is, right, because they're in the same area. At the same time, some router which is far away from in a different area, let's say R10, will not be able to make sense of that particular LSA because they don't know who 0.0.1 is. So your R2, which is your ABR, will take, or in this case R3 as well, right, the ABRs will take the initiative to send out a new LSA, right, which will basically only clearly call out or will clearly tell you how to reach the ASPR, right? So that is your type 4. So your type 5 and type 4 are kind of like complementary. Okay, great. What else? Okay, so the next interesting thing which I also want to call out here is the summarization. So we can talk about external summarization now, right? So what is external summarization? We know that there are routes coming in from here into my OSPF. Now how about, is there a way to summarize those routes, right? So what are these routes? We already looked at them, didn't we? We looked at these routes on my, say, R2 itself. We saw these routes earlier. Here you go. So these are the routes which I'm talking about, right? We did show IP route and OE2 route. These are the OE2 routes, right, which are basically the EIGRP routes which got learnt on OSPF after I did the redistribution, right? Now my question is, can we summarize these routes? What if I don't want all of these routes to be learnt on R2? I just want probably like I don't want such a huge routing table. I want to summarize these routes. Can that be done? Yes, that can be done, right? Or even on, you will have the same routes even on my R4 as well as R10 as well, right? They will be there on R4 and R10 as well. I can show you that, right? So I can probably go to R4. Let's do this. If I do show IP route included, let's just concentrate on probably 207.1 now, right? You can see these are the EIGRP 207 routes. You also have 208 routes, right? So you can see these are all the EIGRP routes which got learnt. But what if I want to summarize this? I can do that. So I go back to my R1, which is my ASPR, right, and I do this thing. So you can follow the command here. So it's router OSPF1, go inside OSPF, summary address. You say summary address, and we have done the summarization a lot of times here, so I'm going to directly do it. If you look at this, let's see, R4, right? So it's going to be the first address always, not always. I mean, we have done how do we summarize this, but let me directly use it here. You can look at the old discussions on how we summarized, right? So 255, because there is 4567, I can use the mask of 252, right, .0, right? Similarly, I can summarize the other network as well, right, which is 208, which is learned from R8, right? There you go. So I summarized it. Now if I go back to my R4 and if you run the same command, there you go, it got summarized, right? We don't have 4 routes anymore, right? The routing table has been reduced back to just one route concerning 207. Similar is the case with 208. You can see here these 4 routes got condensed into just one route. So that is how you can summarize external routes, right? Now we can repeat the same thing. What did we do? We summarized these routes when they were flowing from here to here. We can do the same thing for RIP as well, right? From RIP also we are learning some routes. So if you go to my router, say R6, right? So R6 is my ASPR, so here is where you will summarize. But let me also show you on R5 how will they look, right? So if I go to R5, let me clear this, enable. So it's just going to be same thing with 109, right? So these are your, maybe let me do 109. Yeah, so these are your RIP routes, right? And there are 4 different routes right now. But if I go to my R6, which is my ASPR, and if I summarize, I can basically reduce those 4 to just 1, right? How do I do that? Similar process, router OSPF 1 and summary address 109.1.4.0, right? Similar mask which I used earlier. It's 252.0. So we have done this, right? Figuring out what is the mask and stuff in the earlier videos in RIP and EHRP. We have done this. You have to write down all the octets and try to figure out the number of bits which are common and all of that. You can refer to my earlier discussions on that. But once I do the summarization, you can see on my R5, you can see the change. So there you go. It's been reduced from 4 routes to just 1, right? So that's how you can summarize. You can summarize the external routes, which is fun, right? Great. What else? What do we look at next? Inter-area filtering. The next concept which I would like to talk about is inter-area filtering. What is inter-area filtering? So now you look at router, let's probably look at inter-area, right? So we are just talking about OSPF now, no more EHRP RIP. We are just talking about OSPF because we are talking about inter-area filtering, right? Between areas and not within the area. That's why I'm calling it as inter-area. So you want to filter some routes. You don't want some routes to go from this area to this area, right? So that's basically why I'm calling it as filtering. So let's go back to my router 4, right? If I go to my router 4, let me clear the screen, and if I do show IP route, let's say the connected ones, we have 444 and couple of other ones, right here. So now if I go to my router 1, right, let me do this, show IP route, right, and include the 44 route, right, because I see a 44 route here. Now let's see, do I have the 44 route here as well? Yes, it is a OIA route, it is the inter-area route, right, which was learned here. If I probably go here, so this is the 44 route which is here, and it was learnt on my R1, right? Now my objective is to filter this, which means I don't want this 44 route to be learnt on R1, right? So in such a use case, if you have such a use case where you don't want a particular route to be learnt on a different area, how do we do it, right? So in that case, it's basically what you're doing is you're trying to filter out type 3, right? These are nothing but OIA is basically your type 3 route. You're filtering out your LSA, type 3 LSA. Right, now you can do this in 2 ways. You can do it either, so obviously you do it on the ABR. You do it on ABR. What is ABR here? Router 2, because that is, ABR is the one who advertises type 3, right? So you have to do it on ABR. So we go to ABR. But you can do it in 2 ways, right? Why we can do it in 2 ways? Either we can do it on area 10. So inter-area filtering, you do it is area perspective, right? You do it either on area 10 or you can do it either on area 0, right? So if you're doing it on area 10, you will be basically telling filter out the routes which are going outside area 10. If you're doing it on area 0, you'll basically be telling filter out the routes you're doing which are coming inside area 1. Right, so you'll understand that when I do the configuration. So if I have to go back to R2, now you do this using prefix list, right? So we create a prefix list, IP prefix list, give a name to it, ABC, and we deny, what we deny? We deny the 44 network because we don't want it to be learned, right? We say 44.0.0/8, and the rest of the networks we have to permit, right? So we do prefix list, same thing, ABC permit, and 0.0.0/0 less than 32, right? This is basically like your ACL entry where you say permit IP any, right? We don't have any in case of prefix list, that's why you use this. Now once you do that, now you can go to router OSPF 1 and you say area 10, right? I'm trying to do with respect to area 10, so I'm on R2, I'm saying area 10 filter, use the keyword filter, right? Filter list, which is you're basically using a prefix list here, right? So a prefix list, what is the name of the prefix list? ABC. So you're saying in for area 10, right, when the routes are going out of area 10, right, you want to do it outside when the routes are going out, so you need to specify out, right? So what does the statement actually mean? It means that when on the area 10, when the routes are going out of area 10, please apply this prefix list where we are denying the 44 routes to be advertised to the other area. So when you hit this, what happens? If you go back to my R1, earlier we were learning the 44 route, but now you see we don't have the 44 route anymore, right? So we kind of filtered, we prevented the 44 route to be learnt on my R1, right? Now the same thing you could have also done, saying that area 0, right, area 0 filter prefix list ABC, but instead of doing out we could have done in as well. These both statements have the same meaning, right? Either you are doing outside the routes going out of area 10, or you are doing it the routes which are coming inside area 0, right? Both of them have the same meaning, so right, you can do either of them, right? So that was basically inter area filtering, right? Got that? The next thing which I also want to show you guys is you might have a question, why did we do just inter area, why can't we do intra area, right? Can we do filtering within the area, right? Let's say I don't want R4 to learn something from R10, right, something of that sort. Can we do that? Now no, it's not a good idea to do that. Why? I can actually show you, right? The reason is because in OSPF the routers, they basically exchange LSAs and not routes, right? They don't exchange routes, they exchange LSAs. So let's say we put a distribute list on say R2, right? Where is R2? Here, R2, to block the route from R1. This route will be blocked on the R2's routing table, but we also know that the LSAs are propagated as is inside the area, so R3 will still get the LSA, right? And because it is getting the LSA, it will then put that route in the routing table as well, right? So to understand this better, I can probably take an example. Maybe let's look at R10, right? Let's look at R10. Let's go back to R10, right? Let me clear this, enable. So if you see at R10, let me see if there is a show IP route include connected, right? So I see we have this 100 route, right? Let's pick this 100 route. Okay, so we have a 100 route here. Now if you see it is advertised on R4 as well, right? If I go to R4, you can see I will have them, if I do show IP route include 100, right? You'll have it here. Reason? Because it is in the same area. Something was there on R10, it got advertised on R4, and R4 is able to see it. Great. Now let's try to block this 100 network on R4, right? What happens if you block? So how do you block? We'll use an access list. 1 deny 100 what is the network? 100 this network, right? Let's try to block this. 0.0.0 and 255. Is that right? sorry, /8, right? So 255 5 255, yeah. So I have a deny statement. Now access list 1 permit any the rest of the networks, right? So once you define the access list, what I could do is I could go inside router and OSPF 1 distribute list is the command I can use to kind of accomplish this. Distribute list 1 and which interface, right? Which interface are we talking about? So it's 0/1. On this interface I want to block, right? Distribute list in direction and Ethernet 0/1, right? There you go. Now if I run the same command here again, show IP route, let me do a do here, you'll see that I don't have this 100 network anymore, right? In the routing table of R4 we don't have the 100 network, but right, but the LSA will still have it. The LSA will still have it, right? Why? Because the distribute list, whatever command you used here, it basically prevents the route from reaching the routing table of R4. But if I do something like show IP OSPF database and you do router, right, you will still have this 100 network, right? Let's scroll down. Yeah, there you go. So see, we still have the 100 network in the database, right? Because the distribute list or whatever filtering you do, it's basically only for the routing table, and because it is there in the LSA of R4, it gets propagated to my R2 as well. So if I go to my R2 and if I do something like show IP route include say 100, you can see here R2 still has it, right? Now R2 still has it, but if I hit a ping, right, it will basically end up in black holing, right? Because let me look at this. So show IP interface brief, right? So if I do a ping to this R10 from now R2, it won't go through. Why? Because it is not there in the routing table of R4, right? So we have ended up creating something called as traffic black hole, right? So that is why filtering of routes within the area, right, is not good, or it's not a recommended way to do it, right? It is different when you talk about EIGRP and RIP, because there routers, they exchange routes, right? And if you are applying or if you are doing any kind of filtering, it would kind of propagate everywhere. But in this case, since routers exchange LSAs and the filtering whatever you do is applied only to the routing table, right? So if you do a filtering on R4, right, the routing table of R4 will not have the 100 route, but at the same time the LSA will still have it, and because the LSA is still having it, the LSA will be propagated to R2 as well, and R2 will pick that LSA and update its routing table, right? But because this guy doesn't have it in the routing table, so even though you ping from R2, right, the packet will not, there is no path at all, and it will end up being like a traffic black hole, right? So that's another interesting thing. The next topic which I also want to talk about is the inter-domain filtering. We have been talking a lot about filtering, and we did inter-area filtering, right, which was allowed. Intra-area or within the area filtering is not allowed. The other filtering is inter-domain, right? When we are talking in between the routing protocols, can we do some kind of filtering, right? To understand this, let's go to probably R8. Go to R8. If I do show IP route, probably include connected, we can see that there is a 88 route here, right? Great. Now it is learnt as EIGRP route on my R1. Do you agree? We can look at that as well. So show IP route EIGRP, right? You will see here 88, right? Now when my ASPR sends out this type 5 LSA summarizing, or basically not summarizing, type 5 LSA, which is the external LSA, right, my rest of the OSPF network also gets this 88 route, right? I can verify that by going to R2. Let me clear this. If I go to my R2 and if I do show IP route include 88, there you go, I have it as a OE route, right, on my R2, and rest of the routers in OSPF will have this. Now my objective is that I want to filter this route which is coming from EIGRP. I don't want to learn it. I don't want my OSPF to learn this. So I go to my R1, clear the screen a bit, right, I go to my R1, probably create an access list 1, deny. What do I deny? I don't want to learn this, so let me take this network, put it here, and 0.255, right, and access list 1 permit any, right, basically it's any. Now you then put a route map, right, because anytime you want to do filtering between routing protocols, you have to always use route map. Let's say Ethernet to OSPF, right, E to O is what I call this route map as. I'm matching IP address based on this access list, which is 1. Then what I do, right, then I go to router, my bad, router OSPF 1, okay, I do redistribute EIGRP 100, right. So I have done this redistribution of router EIGRP before, haven't I? But now I'm going to do it. Probably I can remove the old redistribution command, so that, let me see, what do I have it, to show run section router. Let me remove the old one, which is, where is this one, right? I mean the subnets, I think I just did this one. So if I just remove this piece and do it once again, so I'm going to remove it and then do it again, but now I'm going to attach the route map which I defined here. What is the route map name? This one. So once I put that, right, now if I go to my rest of the network, which is R2, and if I hit this, you can see I no longer have the 88 network, right. So what I did, I basically went to my ASPR, which is R1, and I created a route map attaching the access list, right. I matched the access list of the network which I wanted to deny. Then I went to my OSPF, right, I went to my OSPF over here and redistributed the EIGRP, but this time I redistributed by attaching the route map to it. And that way you can prevent or interdomain routes, right, you can filter the interdomain routes as well. Great, awesome.